Hello there, students. Welcome to today's Explainer. I am your sensei for today, and I'm just so absolutely thrilled to have you here in our classroom. Today, we're going to unlock the secrets of a really important scientific concept, and that is volume. Seriously, by the end of this lesson, you're going to see the physical world around you in a totally new way, because you'll know exactly how to figure out how much space everything takes up. Now, don't worry if this sounds a little complicated at first. We've got it all broken down into simple, bite-sized steps. Our roadmap for today covers what is volume, measuring regular shapes, liquid volume in vessels, reading the meniscus, irregular solid objects, and then a quick lesson recap. Section 1. What is volume? Understanding space. Let's dive right in. Okay, so the absolute most crucial thing here is just understanding what the word volume actually means. Very simply, volume is the space occupied by a substance. And, that substance can be a solid, a liquid, or even an invisible gas. Think about it kind of like this. If you have a small teacup and a giant bucket, you intuitively know the bucket takes up way more space, right? Or if you compare a big living room to a tiny closet, the living room obviously has way more space inside it. Well, that amount of space, that's its volume. Now, in science, we need standard ways to actually measure these things. We can't just say it's about a bucket size. So for volume, our standard international system, or SI unit, is the cubic meter. We write this as an M with a little 3 at the top right. Imagine a giant box where every single side, length, breadth, and height is exactly 1 meter long. That is 1 cubic meter. It's fantastic for measuring large spaces. But what about really small things, like a matchbox? Well, for that, we use a much smaller unit called a cubic centimeter, written as cm with that same little 3. Moving on to Section 2, measuring regular shapes using math formulas. Let's say you have a block of wood, shaped perfectly like a cuboid. To find its volume, you really just need a basic ruler and a super simple math formula. You measure the length, you measure the breadth, and you measure the height of the block. Then, you just multiply all 3 of those numbers together, length times breadth times height. Boom! It literally is that simple. And this basic idea brilliantly illustrates how we can use math for all sorts of perfect shapes. For a perfect cube, you just multiply the length of its side 3 times. For a cylinder, like a perfectly straight pipe, it's pi times the radius squared times the height. We even have cool formulas for round spheres and pointy cones. Now, please don't let the math overwhelm you here. These are just really handy, practical tools scientists use to calculate space without having to measure every single millimeter by hand. So, okay, we can measure a perfect, hard, solid, like a cube, using a ruler and some math. But wait, what about something that doesn't have a perfect shape? How on earth do we measure messy, splashy liquids? That brings us to Section 3, liquid volume and vessels, lab tools and units. When it comes to liquids, we actually use slightly different terms. The volume of liquids is generally measured in liters. We use a capital L for short. But just like with our solids earlier, we need a unit for much smaller amounts, too. So we use milliliters, written as ml. 1 single liter equals 1,000 milliliters. And hey, here's a super cool science fact for you. 1 milliliter of liquid is perfectly exactly equal to 1 cubic centimeter of space. Now, obviously, you can't exactly use a straight ruler on a puddle of water, right? So in the science lab, we use special glass containers of a known capacity. Some really common ones you're going to see are the measuring cylinder, the round-bottomed measuring flask, a small dropper-like tool called a pipette, and a tall, thin tube called a burette. All of these have special, exact markings on them, so we can pour a liquid inside and read exactly how much volume it's taking up. Section 4. Reading the meniscus. Accuracy in the lab. But wait just a second. Before you start reading those numbers on the glass, there is a very, very important trick you need to know. If you look really closely at water inside a measuring cylinder, the top surface isn't actually flat. It's not. It curves downward slightly, clinging to the sides of the glass. This curved surface is called a concave meniscus. To get a truly accurate reading, you must not look from way above it or way below it. You have to bring your eye perfectly level with the absolute lowest point of that downward curve. That bottom center point, that is where you read the true volume. All right, Section 5. Irregular solid objects. Beyond perfect shapes. You're doing a fantastic job so far. Now, we're going to face the ultimate challenge in our lab today. What happens when we have a solid object, but it isn't a perfect cube or a sphere? Let me ask you this. How do you measure the volume of a totally weirdly shaped rock? Think about it. It has no straight sides, no perfect radius, no math formula in the world is going to work for this. Any guesses? Well, we are going to use the absolute magic of water displacement. Here is our first brilliant lab technique for this, the measuring cylinder method. Step 1, you fill a measuring cylinder with water and record that starting volume. Let's just say it's exactly at the 50 milliliter mark. Step 2, take your weirdly shaped rock, tie a fine little cotton thread to it, and gently lower it into the water until it is completely submerged. Step 3, watch that water level rise. It rises because the solid is literally pushing the water out of the way to make room for its own volume. Record this new higher water level. Step 4, simply subtract your first volume from your second volume. The difference between those two numbers. That is the exact volume of your rock. Amazing, right? Let's look at our second method, which honestly is just as clever, the overflow jar method. An overflow jar is simply a vessel with a little spout on the side. You fill the jar with water right up to the very edge of that spout. Next, you place an entirely empty measuring cylinder directly underneath to catch any drips. Then, just like we did before, gently lower your solid into the jar. Because the jar was already completely full to the brim, the new space the solid takes up will force water directly out of the spout and spill it into your measuring cylinder. All you have to do is read the volume of the water that spilled over. That spilled water is precisely equal to the volume of your solid object. And finally, Section 6, Lesson Recap, Reviewing Volume. Congratulations, everyone! You've successfully completed your lab work today. Let's just do a really quick review of our top takeaways. First, remember that volume is simply the space occupied by any substance, whether it's solid, liquid, or gas. Second, for standard measurements, we use the cubic meter, but for smaller things, we switch to cubic centimeters or milliliters. Third, if an object has perfect regular sides, we can just calculate its volume using straightforward math formulas, like length times breadth times height. And finally, if we have an irregularly shaped solid, we can use measuring cylinders and overflow jars to find its exact volume through the amazing science of water displacement. You all did absolutely incredible work today. Now that you have all the tools to measure the space that absolutely everything takes up, I want to leave you with one final thought to ponder. If you grabbed a measuring tape right now, what do you think is the total volume of your very own bedroom? Think about how you'd calculate it. Keep exploring the amazing science all around you, and I will see you next time.